Okay. Specific latent heat. Okay. Before we masuk specific latent heat, let's recall first what we learned in 4.2. 4.2 kita learn apa? Specific heat capacity. Maksudnya yang ini adalah satu ukuran bahan. It's a measure of a substance that how fast you can get hot and cold. Kalau specific heat capacity-nya rendah, low, that means the object can get hot or cold faster. Okay, and conversely, if it's the specific heat capacity-nya high, and then it is take a longer time to get hot or cold. And what is the formula? Q equal to MC theta. But this Q is not specific heat capacity. Q ni adalah heat energy. Mana specific heat capacity kamu dekat sini? You kena susun balik formula ni. Jadi, you punya specific heat capacity depends on heat energy, mass of the object, and also the temperature change. Betul tak? Okay. You kena tahu benda ni dulu. Okay, sekarang kita masuk latent heat. Okay, in this latent heat, and also, what is the proper definition of specific heat capacity? Amount of heat energy needed or required for a 1 kg substance to raise its temperature by 1 degree Celsius. Betul tak? Irka Gabriel, Itachan. அப்படி இருக்கணும் definition. Okay. Right. Yang ni 1 kg bahan ni dia perlukan berapa banyak heat so that it can raise its temperature by 1 degree Celsius. Okay. Latent heat pula. Okay. Before you understand latent heat, specific latent heat, you kena tahu dulu apa tu latent heat. Okay. Now, let's go to the subtopic. Matter can exist in 3 states of 3 phases of 3 state. We all know this, right? Solid, liquid, gas. For example, water in the solid we call ice, in liquid we call water, and in a gas phase we call steam. Okay. A change in phase of matter from one phase to another, maksudnya dari solid ke liquid ataupun liquid to gas and whatever, from one phase to another phase at specific temperature and pressure. Okay, perubahan fasa ini hanya berlaku pada a specific temperature and a pressure. Normally, they will absorb the heat or release the heat. Okay, and then followed by the change in the volume and density of the substance. This one to confirm the phase already changes. So now, what is latent heat? Latent heat is heat absorbed or heat released at constant temperature during the change of phase. Yang ini adalah heat energy during the change of phase. Kita belajarkan dalam heating of naphthalene. Ini solid, ini liquid, this is the melting point. Remember from the graph? Di sini heat dia punya suhu dia tak akan berubah, betul tak? Constant temperature. And di sini berlakunya perubahan fasa. Did we already learn this in our chemistry? Okay? It's the same thing. Tapi jangan guna explanation fizik untuk chemistry dan chemistry punya untuk physics. Kita akan belajar benda yang sama tapi in terms of more physics in it. Okay. So, kita cuba tengok dulu. Kat mana kita ada latent heat? Okay, nampak? The first one, this is solid. This is liquid. Solid pergi ke liquid, kita panggil dia melting, betul tak? And liquid pergi ke solid, kita panggil freezing. Okay, dekat sini, ini dipanggil sebagai specific latent heat of fusion. Specific latent heat of fusion. Fusion bukan bermaksud melebur saja, juga membeku. Okey, yang ni kita panggil specific latent heat of fusion. Okey, dekat sini. Liquid pergi ke gas, boiling or evaporation. Gas nak pergi ke solid, liquid, condensation. Kedua-dua ini kita panggil specific heat, latent heat of vaporization. Okay, so specific latent heat of vaporization. Okay, ini yang kita nak belajar. Okay, dekat badan you see melting and boiling is latent heat is absorbed, but for the condensation and freezing, latent heat is released lah. Heat release, heat absorb, kamu tahu kan? Okay, jadi kita nak belajar dua benda ni saja. Specific latent heat of fusion, specific latent heat of vaporization. Dua-dua benda yang simple je. But then let us compare and contrast sikit dengan apa kita belajar dengan 4.2 Dalam 4.2, this is 4.2, this is 4.3. Okay, ini temperature change. Yang ni phase of matter. So what we can sum up from 4.2 and 4.3, dalam 4.2, your temperature change, betul tak? Okay? Tetapi phase of matter constant. Dia tak melibatkan perubahan jirim. Okay? It's not like solid. They never talk about the conversion of solid to liquid, liquid to gas. Okay? Tapi 4.3 your theta is constant, but your phase of matter change. Itu saja perubahan dia. Faham tak? Maksudnya saya tadi lukiskan satu graf. Okey. Di sini kita kena pakai MC theta. MC theta sebab suhu dia berubah, nampak? Di sini suhu tak berubah kan? Ini kita panggil ML. Latent heat, specific latent heat. Okey, semasa temperature tak berubah, you pakai MC theta, bolehkah you kira? Pakai logik sikit. You akan dapat kosong, betul tak? Sebab temperature tak berubah, maksudnya tak berubah, dia akan jadi kosong apa value ni. So, dia adalah Q equal to ML. Okay. Now, what is specific latent heat? Okay. Nanti dia akan jadi, kita kena modify sikit masa dia enter vaporization or fusion. Okay, now this is the general form of this specific latent heat. Quantity of heat absorbed or released during the change of phase of 1 kg of the substance, must maintain that without any change in its temperature. So, definition dia panjang gila. Jadi, kamu kena break down into a few statement first. Okay, first statement, you kena cover apa? Quantity of heat absorbed or released. Selalu kalau you nak hafal definition, you jangan baca ayat yang panjang banyak kali tau. Yang tu tak akan efektif. You nak fahamkan satu statement yang panjang gila, you kena, you must make a partition, the long sentence, into a few partitions. Okay, like apa yang cikgu buat. Quantity of heat that is absorbed or released. Okay. When? During the change of phase of what? Of 1 kg substance. And what is the syarat? Without any changes in its temperature. So, quantity of heat absorbed or released during the change of phase of 1 kg without having any change in temperature. Jadi formula dia apa? Q equal to ml. You boleh pakai L besar ataupun L kecil, up to you lah. It doesn't really matter. It's just a notation. Okay, dia kena sebenarnya macam ni lah. ml tu. Okay. So, how about the unit for the specific latent heat? Jadi kita kena asingkan L dulu. So, what is Q? Heat energy. Joule lah kan? What is M? Mass. kg. Kita naik atas dia jadi joule per kg. Betul tak? Jadi, sebab tu dia punya unit joule per kg. Okay. So far okay? Any question? Okay. I forget your name. Alicia. Okay, sorry. Tak cukup tidur ah. Saya dah lupa semua. Okay, ya. Yeah. Alicia. Jadi, one of the student also saya dah lupa nama dia. Okay. Sometimes kalau you overpack with the new information kita download lambat sikit. Okay. Specific latent heat of fusion, specific latent heat of vaporization, dia ada simbol spesifik dia lah. Kita panggil LF untuk fusion. Fusion only can happen at when melting and also freezing. Yes. Masa melting you kena pakai heat absorb, masa freezing you kena pakai heat release. And also for latent heat of fusion of vaporization, yang ni kita panggil untuk boiling atau evaporation and also condensation. Okay, jadi kita banding dan beza sikit specific latent heat of fusion LF dengan LV, specific latent heat of vaporization. Okay. Yang dua-dua pun kita pakai specific latent heat of fusion. Maksudnya quantity of heat absorbed during melting. Definition yang sama, just dia dah mention fusion secara spesifik kan. Jadi kita kena tambah melting and also freezing. That's it. Faham tak? Your just now definition is the same thing. You kena tambah proses saja. Okay? Quantity of heat absorbed during melting or quantity of the heat release during freezing. The same thing lah. Of 1 kg substance without any change in temperature. Okay, di sini tak payah cakap change of phase sebab dia dah bagi tahu proses. Faham tak? Itu beza dia. Okay, kalau latent heat of vaporization LV quantity of heat absorbed dekat sini kan? Heat absorbed during boiling or the quantity of heat release during condensation of 1 kg substance without any change in temperature. Okay. Now, let's learn about the experiment to show the specific latent heat of fusion. Sekejap aja kita nak habis dah. Okay. Okay. Now, experiment to show the specific latent heat of fusion. Latent heat of fusion ni dari solid to liquid ataupun liquid to solid lah. Jadi kita guna melting dekat sini. Okay, apa kita akan buat? Okay, kita tengok firstly you measure the mass of water here first. Okay, let's say 10 cm3. Let's say lah. Okay, lepas tu kita masuk dekat sini immersion heater. Heater will supply the heat to the ice. Betul tak? Dekat situ you boleh pakai MC theta lah sebenarnya. Okay. Anyway, Q equal to PT. Kalau kita, ada heater saja, kita boleh gunakan Q equal to PT. Okay. Lepas akhir the experiment, kamu dapat 30 cm3. Maksudnya, your mass is 20 cm3 lah. Okay. Mass of water tu dia naik sebagai 20 cm3. Dengan tu kita boleh kira dia punya ni lah. You jangan takut-takut untuk kira yang ni lah. Sebab Okay, how to calculate the specific latent heat? First, you kena pakai Q equal to PT. Why we use this formula? Sebab heat supplied by the heater is equal to the heat energy supplied to the ice. Okay, and then kita guna Q equal to ml. Tadi Q kan is equal to PT, betul tak? Jadi PT equal to ml, betul tak? Okay, dan L ni kita jadikan subjek PT over M. Macam mana kita nak cari PT? M, the final mass minus the initial mass of the water, betul tak? Sebab tu formula dia jadi macam ni. Tak payah hafal formula tu, saya bagi kamu fahamkan saja. Why they use the formula pelik-pelik. Dia sebenarnya sama je. Dia susun. Okay? Sama je kan? Masa 4.2 kita banyak guna PT equal to MC theta, betul tak? Same thing. Kalau you nak gunakan vaporization pun sama. Dia punya setup macam ni. Kita akan letak beaker, water semua. Kita guna tissue paper to wrap. Why? Because to reduce heat loss to the surrounding. Tulis to reduce heat loss to the surrounding. Okay. So, mula-mula, let's say this is a 500 gram. After you conduct the experiment, you left with 425 gram. Dia akan berkurang. Tahu tak kenapa? Fikirlah, kenapa berkurang? Bertukar menjadi watt. Okay, because the water already converted to the steam. This is vaporization. What else you all expecting? Boiling, right? So, maksudnya the 75 gram is becoming the mass of the steam. So, also use the same formula. Okay. Now, step to calculate. Okay, ready? Okay, first thing, we know that heat energy produced by electrical heater will be absorbed by the substance, right or not? So, heat supplied equal to heat absorbed. Ini cikgu dah ajar from 4.2 itself. Sebab tu, heat supply nya adalah power multiplied by time. By the electric kettle or electric immersion. And Q ni, kita letak Q je lah, absorb. And then, assume there is no heat loss to the surrounding. Heat released by the heater is equal to the heat absorbed by the substance. Jadi, heat released now becoming the PT. Heat absorbed becoming the ml. Okay. Kalau ada perubahan suhu, guna MC theta. See when to use MC theta, when to use ml. They will combo. Okay, kita akan gunakan MC theta when the temperature change. Kita akan gunakan ml when the physical state change. Kalau temperature change, physical state constant. Kalau physical state change, temperature constant. Okay? Now, let's see this heating curve. Okay. Tapi di sini kita tak boleh guna the chemistry explanation. Remember why the temperature does not change from A to B. You akan cakap apa? Heat energy is absorbed to overcome the force of attraction between naphthalene particles, naphthalene molecules. Be specific in your answer lah. Ini chapter 2 kamu kan? Okay. Okay. Now, see here, solid is heated until the melting point. Sebelum tu you kena tahu dalam physics ke apa-apa sajalah, kenapa temperature naik? when your kinetic energy of particles increase, your temperature will increase. It's not because you supply heat sebab tu kinetic energy particles increase tau. It works in both way. Okay, kalau you know the particles, the atom, ions, right? Okay, kalau dia punya movement dia increase, that means the kinetic energy of the particle increase, temperature akan increase. You kena hafal benda ni to faham this section very well. Okay? Now, solid is heated until the melting point. So, this is your melting point. And remember, melting point is also known as freezing point. It's the same thing. Dia tak akan berubah. Heat absorbed is used to increase the kinetic energy of the molecule. Nampak dah? Di sini kinetic energy increase dah. Maksudnya, theta akan meningkat. Oleh sebab theta akan meningkat, kita gunakan di sini Q equal to MC theta. Faham? You panaskan. The heat energy absorbed. By what? By the particles, right? Particles tu example molecules lah. Okay, so heat energy is absorbed. So when you absorb the heat energy, what happens to the kinetic energy? The particle will move faster, correct or not? Moving faster is kinetic energy lah. Betul tak? So kinetic energy increase. Kalau kinetic energy increase, remember the golden rule? Temperature meningkat when your kinetic energy of the particle increases. Okay, dekat sini. At the melting point, latent heat absorbed to, you tak boleh guna to overcome the force of attraction all, to weaken the bond first. To weaken the bond between molecules. So, dia tak pakai untuk untuk particles, Macam tadi, heat energy ni kita pakai untuk particles, betul tak? Molecules. To increase the kinetic energy. Di sini dia gunakan heat yang diserap tu to weaken the bond between the molecule. That means your kinetic energy doesn't receive any dia tak berubah. Okay, constant. Your kinetic energy constant, so do your theta. Betul tak? Your temperature will be constant here. Once your temperature constant, gunakan Q equal to ml dekat sini. Macam tu. Okay, simple je subtopik ni. Okay, next. Suhu naik. Nampak ni temperature naik. Liquid. Now it become totally liquid. Liquid is heated until boiling point. Okay, so this is your boiling point. Okay, so dekat sini, now it's no longer ice molecule, it's a water molecule, right? So your kinetic energy of the water molecule increases. So your temperature also increases until it reach the boiling point. Tadi weaken saja kan? Sekarang latent heat is absorbed. You tak boleh cakap heat energy absorb, latent heat. Macam mana nak tahu pakai latent atau tidak? Nampak tak di sini tiada perubahan suhu? Guna latent heat. So, latent heat absorbed to break the bond between the molecule. Dekat sini, kinetic energy dia tak bagi untuk particles untuk meningkatkan kinetic energy. So, the temperature tak meningkat lah. Dia guna untuk break the bond. So, kinetic energy become constant here. So do the temperature. And finally, it become gas and rises up. So gas is heated. Heat absorbed is used to increase the kinetic energy. So the temperature increases. Okay. So maksudnya, sorry I forget. This one you use Q equal to ml. Yang ni temperature naik what? So Q equal to MC theta. Kalau you tak ada theta, you nak ganti apa dalam ml tu? Okay, kalau ada theta berubah, mestilah Q equal to MC theta. Okay. So I hope you get a clearer picture Okay, dekat sini apa keyword yang kita kena guna? Weaken the bond, while here break the bond. Okay, sekarang untuk cooling. Untuk cooling, ini cooling. Okay, from gas. Now this is cooling graph. Gas is cooled down to the boiling point. Okay, so that is 100 degrees Celsius lah. Okay, heat is released. Okay, so haba dibebaskan. Kalau haba dibebaskan, your particles mula lose the momentum, right? So your kinetic energy of the particles decreases sebab you buat cooling. Maksudnya temperature akan menurun. Temperature will decrease. And here you can use MC theta. Dekat sini pula, ini kita panggil apa? Latent heat of vaporization. Okay. Latent heat release and molecular bond are formed. Sebab tadi dia dah break the bond, jadi opposite-nya adalah forming the bond. Okay. You kena opposite tau. Tadi break bond, di sini forming the bond. Nampak? Forming the bond. Okay. Di sini dia kata weaken bond kan. Jadi dia kena strengthen bond. Nampak? Jadi you hafal satu dan hafal the opposite lah. Okay. Di sini your kinetic energy is constant and so do your temperature. Maksudnya di sini kita akan gunakan ml sahaja. And why the temperature does not change? Because latent heat release is used to form the molecular bond. You can answer simply like that. So kinetic energy is constant, so temperature is constant. Dekat sini pula sama je lah. Liquid cool until the freezing point, heat is released, kinetic energy of the molecule decreases. Sebab you buat cooling, bukan macam tadi kan. So your temperature decreases. Okay, here here you use the Q equal to MC theta. Ini kita panggil dekat sini dia dah masuk freezing Latent heat is released to strengthen the bond between the molecule. So your kinetic energy is 0, that is constant. Okay, so your temperature is constant. And finally, when the solid cool off, heat is released. So your kinetic energy vibrate saja. Dah masuk solid stage, your particles vibrate only, right? So your kinetic energy decreasing, your temperature is decreasing, and you can use Q equal to MC theta. Okay, setakat ni boleh? Alright. Sekarang kita masuk calculation. Cikgu akan tunjukkan 6 calculation saja. 7, 8, 9, 10. Itu your own practice. 7 hingga 12 tu. Okay. Now. Fatina used a heater to supply 3,400 joule of energy to the liquid. So this is your Q basically. Betul tak? If 0.4 kg of liquid change into gas, kalau nampak tak liquid change into gas, maksudnya kita kena pakai Q equal to ml dekat sini. Change of phase. What is the latent heat of vaporization? Maksudnya dia tanya latent heat of vaporization. The LF lah. Okay, so we know that Q equal to ml. ml. So since it's a heat of vaporization, kita boleh tambah the subscript V here. Nah, tambah pun boleh, tak tambah pun tak apa. No problem. So what is the soalan? Dia nak LV kan? latent heat or vaporization kan. So Q over M. Remember, Q heat energy, not the latent heat. Then 3400, then 0.4. So jawapan yang kamu akan dapat 8500. So how to determine the unit? Very simple. What is this? Heat energy. So joule, confirm. Mass kita naik atas. Yes, kg negative 1. Itu saja. Okay. Boleh Okay, next one. Siti cools a pitcher of tea, pitcher P. Okay, using ice cubes. If the tea cool down after ini dia cool down lah. Okay. 10,500 joule of energy. Calculate the mass of the ice that has been melted. Oh, okay. So this is fusion lah. Sebab dia gunakan melting kan. So Q equal to MLF, right? Sekarang dia tanya apa? Mass kan? Arrange the mass first. Q over LF. So your Q is 10,500 joule. Latent heat of fusion of ice sudah diberi 3.34 times 10 to the power of 5. What is the mass? Alicia, what is the answer? 32 3143 kan? You ambil at least 3 atau 4 tempat. That will be a good answer. Okay. 0314. 4 tempat. Okay lah, quite strong. Okay, so this is mass. So letak kg. Okay, next one. Hermione using electric heat. Okay, so far this one okay guys. Dia ada bagi satu vaporization example, satu fusion example. Sekarang kita nak gunakan, nampak tak? Dia dah guna perkataan electric heater, right? Kalau nampak electric heater, kita kena gunakan Q equal to PT. Power mana? Yang mana power? 100 ke 240? Understand? Yes, the one with the V, W, Watt. This is power, this is voltage lah. Nothing related to that. Our question I do here. Okay, initially the mass of the ice was 750 gram. Calculate the time taken so that only 400 gram of ice cube is left. Okay. You all faham soalan? So, dia tanya masa yang diambil lah untuk supaya 400 gram ais saja ditinggal. Okay. Now, I know I need to use Q equal to PT. And Q is also equal to ML. Nah, bagi ini fusion lah. So, combining both equation, kita dapat PT equal to MLF. So, we know that okay, Dacha ini, what is the power?
100, sir.
Okay, 100. Time is what we need to find out. What is the mass?
0.75.
0.75 Okay.
Yes, sir.
0.75. Have to think this one. And what is your LF?
3.34 times 10 power 5.
Yeah, right. Good. So you know everything where is about these things are located, but then you punya mass Ya, dia dah convert 0.75 just now. Tapi masih salah. Alisha? Kena tolak. Kenapa you tolak, Alisha? Why? Baru kita tahu mass of ice yang telah lebur. Kita guna formula ni untuk calculate perkara yang sudah lebur, bukan perkara yang tinggal. Betul tak? Dia nak 400 gram tinggal. Kita tak nak yang ni. 750 minus 400 kena tinggal. So, maksudnya 350 gram kena lebur. Which is 0.35. Careful with the questions. Nampak? Slowly the question get increased difficulty. It's not difficult at all if you are careful enough. Okay? So T equal to 1169 second. Okay. Boleh Okay, next one. Question 4. Irfan use electric heater lagi. Okay. Bulat the power. This is your power. To melt some ice. So fusion. Initially, the mass of ice is 2 kg. If the heater used for 10 minutes, calculate the final mass of the ice. Yang ni pun dia tanya final mass of the ice. Tapi kita boleh guna untuk kira apa yang telah lebur saja. Betul tak, guys? So you need to be careful. Baru saya ajar trik dia kan. Jangan buat kesalahan yang sama. Once dia pakai heater, kita kena gunakan PT lah. And yang ni adalah melting, jadi kita panggil ml. MLF if you want to be very sure. Okay, power dia dah bagi 250. Okay, that one is okay. Time 10 minit. Bolehkah kita ambil minit? Tak boleh kan? Kita darab 60. Mass of the ice that is melted here, M, and LF dia adalah 3.34 times 10 to the power of 5. Okay, calculate your punya mass dulu. Dapat tak? 0.449 kg. But this mass is referring to what? Mass of ice that has been melted. So, what is the final remaining mass? Take the initial 2 kg minus 0.449. Baru you dapat the remaining ice. .551 kg. This will be the right answer. Okay. Next one. Soalan yang sangat famous. Okay, ni soalan difficult Okay, dengar betul-betul. You dah tak buat 6 soalan ini, then there is no difficult question ready. Okay, 6 soalan ni sudah cukup. Okay, soalan nombor 5. Okay, soalan nombor 5, kamu tengok, calculate the total energy needed. That means they asking the Q lah. Total heat energy needed to to change 0.2 kg cube ice cube, dia tak bagi initial temperature at negative 5 degrees Celsius into water. Kalau dia tak bagi, let's see kalau dia tak bagi soalan ni dia ada bagi, saya ada bagi gambar aja kan. So to match the question I put negative 5. Let's see dia tak bagi ni, you start dengan 0 degree Celsius. Faham? You start dengan 0 degree Celsius. Ini cikgu nak bagi to change 0.2 kg ice cube at negative 5 degree Celsius. Okay. You nak letakkan 0.2 kg ice cube ni at negative 5 at negative 5 degrees Celsius into the water with the temperature of 30 degrees Celsius. Okay, so eventually the temperature become 30 degrees Celsius lah kan. Okay, sebab dia nak convert ice cube ni kepada water. So this is latent heat of fusion Okay, jadi you kena divide the stage into a few stages. Okay, you tengok dulu. Mula-mula dia ice. At where? Negative 5 degrees Celsius. Lepas tu dia masih lagi ice, tapi dekat sini 0 degree Celsius. At the same temperature, it become water at 0 degree Celsius. Okay, you all faham Negative 5 to 0 degree Celsius ice. Then from 0 degree Celsius, a melting point and freezing point. So dia akan melakukan perubahan fasa. So it become water at 0 degree Celsius. Then this water will go for 30 degree Celsius. And that's it, right? Okay, jadi you all tengok guys dekat sini. Ini nampak dah temperature dia berubah tak? Temperature berubah, you mestilah you kena pakai MC theta dekat sini. Ini nampak tak? Temperature dia tak berubah kan? 0 dengan 0. Jadi pakailah ml dekat sini. And then back to here, 0 to 30 temperature berubah. Jadi ini adalah MC theta. Faham? So the total energy needed. Okay, first the mass of ice was what? 0.2. So first stage 0.2. And yang ni adalah specific heat capacity of water kita kena ambil. Walaupun dia ice, dia bahan yang sama kan? 4,200. Lepas tu theta. Negative 5 to 0. 5 je lah kan beza dia. Ini phase 1. I mean stage 1 lah. Nanti you akan ni confused dengan phase of matter. Okay, the second bracket is representing the ml part the 0.2 and latent heat of fusion, this one is 3.34 times 10 to the power of 5. This is the second bracket. How about the third bracket? 0.2 MC theta again C is the same water 4200. Now the theta from 0 to 30 is 30. Okay lah. This is the total energy. Richardson, what is the answer? 96,200 is the correct answer. Ada tak sesiapa yang belum dapat lagi? Julai. Okay. Okay, final question for the calculation part. Okay, this one. Kita kena tengok dekat sini. Okay, this is 0.2 kg solid X when being supplied with the heat energy from the heater at 200 watt. So, dia dah bagi guna heater kan, jadi Q equal to PT memang ada lah. Okay, now the question is, nampak tak benda ni dia boil at 80 and melt at 60, so it must be a covalent compound lah. Okay, can be a covalent compound. You can relate each bit with your chemistry there, because dia punya boiling point and melting point is relatively lower. Mungkin alcohol lah, alcohol ataupun your naphthalene kan, 78 kan. Okay, state the melting point. Melting point at here, 60 degrees Celsius. Question B. Calculate the specific heat capacity of the solid X. Okay, macam mana kita nak calculate specific heat capacity? Kita kena tengok lah Q equal to MC theta kan. Okay, Q equal to MC theta, C equal to Q over M theta. So, what is the Q? Dia tak bagi kan? Jadi kita kena gunakan apa? PT je lah. PT equal to MC theta, sebab kita tak ada information on. Tak apa, jangan nak erase dia. You boleh modify the equation below it. Q is equal to PT kan. Carilah macam tu. So power dia berapa tadi? Power dia 200. Dan dia cakap untuk solid X kan. Read the question carefully. Solid maksudnya dia nak yang ni sajalah. Betul tak? Ni baru solid, ni liquid. Okay, so just take information from here. The time is what? 35 minute, right? 35 second, right? Careful lah, sometimes graph dia bagi dalam minit. So ini 35 and mass is 0.2 kg lah. And how about the theta? The theta is from 60 to 30. Okay, berapa yang Sam, let me know the answer.
Um, 1166.67.
Yes, correct. 1166.667. Bagi 3 tempat lagi bagus lah. 1166.667. Okay. Tapi kena bagi unit ini tahu Q ni adalah apa? Joule kan? So Joule. And M tu berapa? kg, tapi kena naik atas. Theta degree Celsius kena naik atas. Simple. Okay, next one. Calculate the specific latent heat of fusion X. Okay, specific latent heat you boleh ambil dekat sini pun. Dia kata fusion saja kan? Sorry. Dekat sini ya, fusion saja. Fusion maksudnya dekat sini saja. Sebab yang ni dekat sini adalah vaporization Remember. So Q equal to ml. Dia tanya specific latent heat of fusion. Maksudnya LF yang kena jadi subjek Q over M. Jadi power Q ialah kita boleh tukar jadi PT lah kan. So power multiply by time macam tadi 200, tapi di sini 35 to 75 maksudnya 40 second lah kan. Careful jangan pakai tulis saja. Dekat sini 35 to 75 means 40 second. Okay, how much is the mass? Dia dah bagi dekat sini mass 0.2 kg. So, kita akan dapat 40,000. Okay, Q-nya adalah joule. Mass-nya adalah kg negative 1. And finally, at D, explain why the temperature between 35 and 75 stay the same even though heat is supplied to it. Kalau it depends on the mark if they gave you lah. Kalau 2 markah, 3 markah, 4 markah, 4 markah you kena explain semua lah. So I give you the full explanation. Explain why the temperature stay the same at where? Here. So di sini kita kena pakai the word weaken, betul tak? And opposite to it will be strengthen, betul tak? Di sini kita kena gunakan pakai perkataan break the bond or forming the bond. Okay? Now, explain why the temperature 35 to 75 stay the same. Heat, this is latent heat, right? So latent heat absorb. Latent heat absorb is used to dekat sini adalah peleburan you punya melting. So is used to weaken the what? Molecules what particles we don't know. Because this is solid X punya particle lah. Okay. Latent heat absorb is used to weaken the solid X particles. So, next, you kena bagi tahu, of course, your kinetic energy and also the temperature lah. So, the kinetic energy of particles of solid X constant. Hence, the temperature is also constant. Itu 3 poin dia. Salin? Okay, dah. Okay. Okay, the final part of this subtopic is the application part. Application dia simple je, bukan macam specific heat capacity. Okay, kita pergi dari nombor 2 dulu. Okay, ready? Nombor 1 tu dia technical sikit. You make sure you understand the 2, 3, 4, 5 first. Okay, I want to use our basic example, the sweating process first. Let's see you understand from there or not. So, body felt cold after sweating. Betul tak? Lepas peluh kita kering, badan kita jadi sejuk. Kenapa? Okay, you see ni. Peluh terhasil because of the increased body temperature. Betul tak? So, this peluh, when it want to evaporate, dia serap semua latent heat. Dia serap semua latent heat. Kenapa latent heat? Kenapa saya guna perkataan latent heat? Sebab liquid ni akan tukar jadi gas. Betul tak? Dia evaporate, right? So, because your heat is absorbed here and then becoming the vapors, your body feel cold. Tadi body kenapa dia panas? Sebab dia punya temperature tinggi sebab badan panas kan? Peluh ni masa dia nak menguap, dia ambil pergi bersama-sama dia dengan latent heat. Okay? Simple explanation. So this is because the latent heat of vaporization is absorbed from the body when the sweat evaporates. Okay? Latent heat of vaporization is absorbed. Itu yang keyword dia. Okay, when the sweat evaporates, so as a result, body is cooled by the removal of heat. Okay, can Next is, let's say you want to, kamu nak tuang air kat musuh kamu. Let's say you want to pour water towards your enemy. Don't do it in that way. That one less effect. Dia cedera sikit je. You bagi steam dekat dia. Bagi melecur kuat-kuat. Okay? Tapi don't quote my name lah if you get caught. Okay. Burn from exposure to the steam yang wap air tu lagi teruk tau daripada air panas. Air didih tu. It's worse than the burn from the exposure of hot water or even the boiling water. Boiling water sudah steam. The normal hot water lah. Okay? Biasanya kucing-kucing kena ni. Banyak orang dia zalim. Dia suka tuang air panas kat kucing. Itu satu perbuatan yang tak berperi kemanusiaan lah. Itu yang cikgu selalu nampak. Lagi satu, anjing pula dia orang buat apa? Cat. Dua-dua pun kegiatan yang memanglah manusia kan bodoh. Dia kena, semua ni ada kempen. Nak jaga anjing, kucing pun kena ada kempen. Malaysians very stupid one sometimes. Okay? So, specific latent heat of vaporization of water is latent heat of latent heat of vaporization is larger than the specific heat capacity of water. You faham dah apa dia tulis? LV is greater than the specific heat capacity. Itu maksud dia. You tulis dalam simbol. You boleh faham sekejap je. Okay? Latent heat of vaporization is greater than specific heat capacity. Jadi masa dia condense, kalau steam, masa dia condense, apa dia akan buat? Macam peluh tadi. Dia akan, large latent heat of vaporization is released. Dia serap dan dia pergi. Masa tu, pedih, compared to the hot water. Okay? So, latent heat of vaporization is absorbed by the skin. Kalau kamu steam lah dia. It causes serious injuries or burn to the epidermis and dermis layer. Okay? So, your latent heat of vaporization is greater than C, and when the steam condense, larger latent heat of vaporization is released. You kena explain macam tu. Okay? And how about this one? Preparing a cold drink. Ice cubes are put into the drink. When ice cube melt, absorb latent heat of fusion from the drink. Kenapa ice tu jadi sejuk, air tu jadi sejuk? You boleh explain in terms of thermal equilibrium. And kalau dia minta, tengok soalan lah, kalau dia minta dalam in terms of thermal equilibrium, guna the thermal equilibrium punya formula. Kalau dia suruh gunakan kamu latent heat of fusion, you kena beritahu masa dia melt, apa dia akan buat? Latent heat, dia buat melting untuk apa? Heat absorb kan? Dia buat heat absorption from the liquid into the ice. So latent heat is absorbed from the drink. As a result, the drink get colder. So the drink loses heat. So temperature of drink drop. So during the ice melting, the temperature of mixture of ice and drink maintain at 0 degrees Celsius. Okay, because it's a latent heat of fusion. Okay. And then, kita nak jaga freshness of fish and meat. Okay, we place them in contact with ice, right? So as usual, we know that with a larger latent heat, ice is able to absorb a larger quantity of heat from the fish. Dia tak bagi panas. Masa dia melting, masa itulah dia serap lagi banyak heat energy from the fish. So your fish loses heat. Maksudnya your fish is kept in the low temperature. So food can be kept at low temperature for an extended period of time. And then if you add impurities, it's further down the melting point. Okay, next. Jadi ikan yang kamu tadi sejukkan sekarang nak jadi masak pula. Nak masak, nak rebus ke nak bagi steam? Yang mana cepat masak? You kena jawab steam lagi cepat masak. Saya dah bagi tahu. Steam lagi bahaya kan? Okay. Water has a very large specific heat, latent heat of vaporization. This property, kalau large specific latent heat, apa maksud dia? Dia boleh serap banyak haba sebelum menjadi gas atau semasa menjadi gas. Okay, this property enables steam to be used cooking by the method of steaming. So, what happened when the steaming one? When the steam condense, masa dia nak evaporate, the latent heat is releases directly into the food enable. Okay, sekarang masa dia nak evaporate, yang ni bukan dia bawa bersama-sama macam peluh. Yang ni dia release the heat, kena pada ikan tu. Okay, you kena pandai tengok lah dia heat release ke heat absorb. Enable the food to be cooked faster rate. Okay, find number 1. This is our ice peti lah. Refrigerator. Okay, refrigerator. Okay, dekat bawah tu ada compressor. Okay, I'm going to tell you lah one by one. Okay, y'all kena tahulah benda ni sebab kadang-kadang dia ada soalan trial saya tengok. Dia ada bagi modify refrigerator. Kalau refrigerator you kena tahulah itu adalah 4.3. Okay, baik, macam mana dia berfungsi dulu kita tengok. Nombor 1, di sini dia akan ada satu liquid, we call coolant liquid, maksudnya cooling gas lah. Okay, compressor ni dia bawa apa? Okay, let's say this is the coolants lah. Compressor ni dia akan ada satu piston, dia akan push, bagi dia mampat. Kalau kita buat pemampatan ni, apa dia akan buat? All your cooling agent particles, they move very rapidly, right, in a smaller space. So, as a result, temperature meningkat, pressure meningkat. Okay. Jadi, cooling agent ni, dia akan release at high pressure. Dia masuk dekat sini. Sebab dia tadi gas kan. Ini adalah condenser. Tahu condenser? So, gas, dekat sini dia akan jadi liquid lah kalau dia pass through condenser. Sebab gas to liquid is your condenser. When gas converted to liquid, a lot of heat is released. Betul tak? Heat is released. So, in the condenser, cooling agent, the gas, releases latent heat during the condensation. Releases the heat lah. Okay, now dia menjadi cooling agent, cooling dia menjadi liquid, cooling liquid lah kan. Sebab tu dia guna perkataan liquid. Cooling liquid flow through the expansion valve. Okay, dia masuk valve pengembangan. Okay, dekat sini, apa yang berlaku? In the evaporator, cooling agent, the liquid, evaporate and absorb the latent heat from the refrigerator. Kamu letak makan panas-panas ke apa-apa sajalah. Masa dia jadi liquid, dia buat apa? Dia absorb all the heat from the food, the environment here. Lepas tu, dia masuk balik. Nombor 4. Dia dah serap, dia masuk balik, dia kena evaporate. Di sini dia akan jadi evaporated. Gas tu akan kita pump balik dekat bawah compressor ni. And this process continues. Okay, I repeat again Okay, dengar betul-betul. First, your gas, coolant gas lah. Saya panggil coolant gas, coolant liquid. Okay? Coolant gas kamu kena compress. When your coolant gas get compressed, your temperature and pressure of the coolant gas increased. And this will be flow through the condenser. At condenser, large amount of latent heat is released sebab condenser kan. Okay. So now the coolant liquid pass through the expansion valve. And then kita ada satu box yang kita panggil evaporator. Okay, di sini liquid akan masuk. Okay, liquid will evaporate. But while evaporating, seem like our peluh. Dia absorb semua heat kan? Sekarang dia macam boiling lah kan? Dia semua heat. Okay, dia serap semua heat dia dan masuk balik ke 5. It flow back to the compressor. Itu je. Dekat sini lah makanan tu disejukkan. Okay, at the evaporator there. Okay. So I hope I already explained enough.
So your fridge tu macam kat engine kan?
Yang condenser lah. Yang engine tu radiator. Apa kamu tanya? Dia lebih kurang, tapi dia lain sikit. Dia kena yang itu kita kena suck in the air, right, by the fan. Yang ni tak payah fan semua. Okay. Okay, sekarang kita cuba buat beberapa soalan. ரொம்ப வேலை செஞ்சு கழிச்சிட்டியா? Okay. Let me see. All questions look very juicy. Okay. Okay, kita buat basic question first. Question 3. Okay, ready? Question 3. Ambil question 3. Okay. Diagram 7.2 showed how mass of liquid change with the time during the heating. Okay. Kamu boleh nampak immersion heater here, water, and this setup we already seen before, right? Ini latent heat of vaporization, Okay. Mass of water initially 500. And then after that it drop until 380. So maksudnya air tu apa dia? Menguap. Latent heat of vaporization lah. And time telah diberi dalam minit. Sudah ada satu trap. Mass telah diberi dalam gram. Second trap. This is latent heat of vaporization. Third trap. Sebab banyak orang ingat ni fusion. Soalan ni ada banyak trap. Okay. You kena buat banyak soalan. Baru you boleh buat. Biasakan diri kamu. Okay. What is latent heat of vaporization? Yes. Detection. Heat apa? Vaporization is what? Heat absorb? Fail dia. Alicia?
He absorb or release.
Huh?
He absorb or release.
Or?
Release.
I know it absorb or heat release. Heat absorb during what? Because they asking very specific question, right? You tak boleh bagi umum. Heat absorb during what?
Change of phase.
Yeah, I know. Liquid to gas, proses dia apa? Ah, liquid to gas, proses dia apa? Boiling. Gas to liquid? Condensation. Jadi, heat absorb during boiling or heat release. Nampak tak? Masa kita baca, perkara tu tak ada. When we want to write, baru dia akan muncul lah. What we learn just now? Nampak? Pembacaan hanya efektif 50%. That's why I ask you to write more. Okay? Heat release during condensation of what? Of 1 kg substance. Betul tak? Of 1 kg substance without what? Change in temperature. Bagus. Sudah dapat semua. Saya dah bagi tahu ayat ni panjang gila. You kena buat betul-betul Kalau you bagi latent heat punya definisi saja memang tak cukup. Sebab soalan dia minta vaporization. Okay, boleh Okay, next one. What is the amount of heat absorbed by the liquid during boiling? Dia dah cakap during boiling. Jadi ini adalah Q equal to ml. Confirm. Okay? Confirm. So, and kita juga boleh cakap Q equal to PT also. But which one you want to use here? Your specific latent heat of vaporization is here. So, amount of heat absorbed by the liquid during the boiling. We use the amount of heat absorbed by the liquid is provided by whom? The immersion heater, right? Jadi gunakan Q equal to PT lah, lagi senang. So, power dia berapa? 1000. Okay, time dia berapa? During boiling. Timing? Semua orang ingat, time, take the total time. No, during boiling saja. Kat mana boiling? Many people think, okay, kalau straight macam ni, boiling, betul tak? Tapi yang tu temperature versus time. This is mass of water. Di sini mass dia tak berubah. Dekat sini berubah, maksudnya di sinilah dia tengah boil, betul tak? Boiling tu between 6 to 10. This is boiling. Maksudnya 4 minutes lah kan? Okay, 4 minutes, kita kena darat dengan 60. $240,000 joule. Sebab dia tanya amount of heat saja. And then here we can put the Q equal to ml. And L equal to Q over M. So Q just now 240,000 lah. Itu ialah Q. And dia dah bagi tahu specific latent heat of vaporization. Jadi kita kena kira mass of liquid that has been evaporated from 500 to 380. Another trap. So you jangan ambil 500, jangan ambil 380. You ambil berapa yang kena evaporated. Under 20 gram yang tu. Some more. So 500 you minus 380 and then this is in gram. Jadi tukar kepada kg. So many trap. You really need to be careful when doing the calculation. Kalau you dah buat banyak jenis soalan, you akan tahu di mana akan ada trap dia. Sebab tu saya bagi banyak. You buat sikit dah ni dah. Dah letih lah. Saya dera lah. Macam-macam lah. You bagi tahu saya. Okay. So, kamu akan dapat latent heat of vaporization of this liquid is 2 times, dia besar kan, terus bagi dalam standard form lah, 1, 2, 3, 4, 5, 6, 10 to the power of 6. Betul semua orang dapat ni? Jadi ini joule, ini kg negative 1. Okay, what happened when the gradient of QR in the diagram 7.2, when the activity is carried out at the mountain top? What happened to this gradient? So this gradient actually showing what? How much water is losing, right? So kalau dia losing lebih banyak, dia akan jadi macam ni. Kalau lebih lambat, dia pergi macam ni. Faham tak? Dia memang akan berkurang pada 380. The thing is fast or slow. Sebab this is more towards y-axis. Betul tak? This is more towards the x-axis. We need to, in another word, steeper or less steeper lah. Kalau you pergi mountain, apa yang akan berlaku? Dia lambat, boil kan? Sebab temperature and pressure dekat situ tu kurang. So, dia punya masa yang dia ambil tu, dia akan lebih lama lah. Okay, so dia akan jadi less steeper. Because take longer time to boil completely. Okay, an egg is put into the pot. State the modification for the following aspect so that egg will cook faster. Immersion heater kena high power lah kan? Why high power? Greater amount of heat can be supplied. Betul tak? And how about the specific heat capacity of the pot? Smaller. Sebab kita nak cook faster kan? Tapi kena tengok dulu. Dia nak cook faster lah. Dia letak cook faster, you cannot use that. So, get hot faster lah. High power, greater amount of heat can be supplied lah. Okay, specific heat capacity nya smaller, so get hot faster. Okay, itu sajalah soalan yang saya sempat bincang hari ini. Yang lain kamu pergi try you kena try. Saya dah bagi tahu banyak kali. Soalan ni dia penuh dengan trap. You tak explore, memang you tak boleh jawab dalam final. Okay, we continue this on next class. Take care, bye guys.